Today, we're going to go ahead and talk about end behavior and more specifically how to write the end behavior using what we call limit notation. So remember this arrow on the right and on the left, that's to represent the end behavior. But this one right here, we're going to use the abbreviation LIM where L is in cursive. That is going to represent the limit notation. All right, so let's say I have this end behavior sketched out where the left side goes down to negative infinity and the right side goes up to positive infinity. Up until this point, we've been saying it like that, where the left goes up and the right goes down. Well, now we need to actually start using mathematical symbols and language to communicate that. So let's start with talking about the left end versus the right end. So if we talk about the left end, let's look at what happens to our x values as we go further and further to the left. So if I go further and further to the left on any number line, where positive is on the right and negative is on the left, I could see that I'm heading more and more towards my negative values. So to represent my left end, I'm going to use this symbol, x, and then an arrow pointing at whatever the x values are approaching. So on the left side, we just said on a number line, if I go further and further to the left on a number line, my x values get closer and closer and closer to negative infinity. Okay, so anytime we're talking about the left end, we're going to use this x and then an arrow pointing at negative infinity. So now let's figure out the right end. The right end will be very similar. Let me put underline there. If I look at the right end on any number line, if I go further and further to the right and I keep going and keep going, well, what are my x values approaching? They are approaching, they're getting closer, bigger and bigger and bigger, they're getting closer and closer and closer to positive infinity. So now whenever, instead of saying on the left it goes down and on the right it goes up, we're going to say as x goes to negative infinity, and then we're going to keep filling in the blank. And then on the right, we're going to say as x goes to positive infinity. Okay? So let's see what it looks like for the y values. So if I'm looking at my y values, I want to use the same thing, but I'm not going to use x. I'm going to use what would represent my y values, which is f of x. So remember that y and f of x are the same thing. So what I could say is for this example, if I'm describing the left side of this, if I'm just looking at the left side, then my y values are going down. Well, instead of going down, we want to say, what are they approaching? Well, look at my y-axis. If I go down this y-axis, what are my y values getting closer and closer and closer to? The further I go down, the closer and closer they get to negative infinity. They get smaller and smaller and smaller. So we can say f of x arrow negative infinity, which is the same thing as y arrow negative infinity. And remember that arrow means approaches. So for the left side, f of x approaches negative infinity. So we're not saying y goes down, but the left side goes down. On the right side, we would use f of x arrow. Well, what is it approaching? We have to read it. On the right side, the graph is going up. So we would say positive infinity. So let's go ahead and put everything together, and we're not going to introduce limits until the next example. So let's go ahead and see an example without limits. What we can do is we're going to take this graph and we're going to kind of use nothing but mathematical symbols. And then we'll get to a better way to communicate what is going on here. Okay, so we can say let's start with the left side. On the left side, remember we said the left end will be represented as x approaches negative infinity. So remember, we already figured out if we're talking about the left end, we're going to put x arrow negative infinity. So as x approaches negative infinity, what happens to y, or what is my function approaching? On the left end, where are my y values going? Are they going up or are they going down? You should see that they're going up, so we can say, since they're going up, we're not going to say f of x goes up. We're going to put f of x approaches what number? Positive infinity or negative infinity? And it should be positive infinity. Okay? Now so this is the left end. So we've talked about the left end, which we aren't writing down. We're just making sure you know that that's what we're talking about. The right end is what we need to find now. So as x approaches, well, what do we use for the right? Hopefully we look at a number line. What's on the right? positive infinity. Now we have to look at my graph to see what f of x approaches. What are my y values doing? So if I look on the right side, my function is pointing down, and instead of saying f of x goes down, we're going to say f of x approaches negative infinity. So this is how you would write this. Again, the end behavior of a function without a sketch. We want to write it in mathematical terms. All right, so let's see how we can represent end behavior using a limit notation. So first I want to explain what limit notation is. So limit notation is used to represent end behavior by using these three first letters of the word limit. So if I wanted to represent the left side for end behavior, I would use the limits of my function. Let's say it's f of x in this case, of my function. And then right below the limits, I'm going to draw or write the symbol for x going to the left. So if you notice from the previous video or from the previous part of this video, we showed that the left end is represented by x approaching negative infinity. So that's what I want to put on the bottom of my LIM here, a little x approaching negative infinity. Now it should be small and fit just below it. I don't want you writing a big X arrow at negative infinity. It should fit just below the lim part, not the f of x. So then we would say, well, then we would look at the graph and say, all right, well, what does that equal? Okay, so this is how you'd represent the left side of the end behavior, or the left end behavior. And if I wanted to represent the right side, I would draw the same exact thing, or write the same exact thing, the limit of my function as x approaches. Now I want to represent the right side. So again, I can go back and look what is the right end approaching? What are the x values approach on the right end? It is positive infinity, so x approaching positive infinity, a little one right under that limit. So this is how I would represent the left side. This is how I'd represent the right side. Now, all I'd have to do is read a graph and then answer the question. Is it going up? If so, it would be positive infinity. Is it going down? If so, it'd be negative infinity. So let's go ahead and look at a graph together. So let's look at this function right here. Let's say negative on the left, negative on the right. Down on the left, down on the right. So again, in the past, we'd say the left end goes down, the right end goes down. The previous example had us say x approaching negative infinity, comma, f of x approaching some number. And now, again, we're putting that in a little bit more concise statement. So the left side limit of f of x as x approaches negative infinity, we'd take this graph and we'd see what's going on the left side. So cover the right side. We don't care about this for this problem. As x approaches negative infinity on the left, where's my arrow pointing? Is it up? Is it down? It is down. So the limit would be not down. We would put negative infinity because that's where it's headed. All right. So if I wanted to do the same thing, but for the right side, I would read the right side. The limit of f of x, x approaches positive infinity. That means we're talking about the right side. What's going on here? Is it going up or down? It's going down. So the limit is also negative infinity. So all of this, these two things would represent your end behavior. So when I'm asking for end behavior, you're looking for this limit, the left limit, and you're looking for the right limit as well. And again, just to reiterate, remember the thing that distinguishes left side from right side is x going to negative infinity would be the left side on a number line, remember? And then x going to positive infinity would indicate the right side. So that's the only thing that distinguishes left side versus right side end behavior. All right, so let's finish off what this video was all about. The intention of this video was to explain limits and then be able to use limit notation to represent the end behavior of a function. So right here we have two functions, f of x in green and g of x in orange. It says identify the end behavior using limit notations of each of these. So let's go ahead and start off by writing the limit of the function that we're trying to do. Let's go ahead and start with f of x. And then if we're looking for the left end first, then we would say x approaching negative infinity. This tells me my left end, remember? And then we just look at it. Let's look at f of x and say, what's going on the left side? Where's it going? Looks like that arrow is pointing up. So I would say the arrow, since the arrow is pointing up, I would say it equals positive infinity. So that's my answer. So again, the limit of the green function f of x as x approaches negative infinity equals positive infinity. Then I put a little comma or a semicolon there. And then we would want to do the right side. The limit of f of x as x approaches, what is the right side? Again, we're not looking at the graph yet, but what do x values approach on the right side? They approach positive infinity, which is what we discussed up here as well. So again, we're looking at the function f of x, and now we're looking at the right side, so we can cover up the left side, and we can see that this function is clearly pointing down on the right side. So my limit would be negative infinity. In other words, it keeps decreasing without bound. That's what these are. So we all know we can never reach infinity, but what this end behavior is telling us is, again, where is the graph pointing? Where is it headed? Is it increasing, going up without bound, or is it decreasing, going down without bound? All right, so let's go ahead and see the second function down here. The limit of my function g of x now, this is my function g of x. Nothing changes. We're still starting with the left side, so we're still gonna put x arrow negative infinity. And the only thing I'm gonna change is the actual color of the function. It doesn't matter for your notes, but the limit of g of x is now referring to the bottom function. So we're still gonna look at the left side because x is still approaching negative infinity. That's what we started with. So now let's look at the bottom function, and we're looking at the left side so we can cover the right. And we can say the left side is going up towards positive infinity, so that's my answer, positive infinity. Okay, and then let's do the right side. The limit of g of x as x approaches, well, what does x approach on the right? It approaches positive values, so positive infinity. And then I'm gonna go ahead and cover up g of x, the left side of it, so that I can just observe the right. What is going on the right side? It's also pointing up, which means my limit is also positive infinity. Okay, so remember, we can totally, if I gave you the function without the end behavior, you could totally use this chart to figure out which one of those four end behaviors the outcome is, but then we're using this to represent it using limit notation. Okay, so we're using the sketch to represent it as with a limit notation. All right, so that was the point of this video. Come to class tomorrow with some notes to exchange with your partners. We'll see you later.